We've got another system up here on the board. We can see that this time it's not a linear system. That's a linear inequality, but that's not. All right, directions are the same. I erased them just because they were taking up space. We're going to graph the solution set. If the solution set happens to be empty, if there's nothing that satisfies both inequalities, then we'll show that the solution set is the empty set. All right, so if I work with this first inequality, I know that my boundary curve is x squared plus y squared equals 4. And because this is an inclusive inequality, that's going to be a solid curve. Now, I recognize that as a circle centered at the origin of radius 2. So I can draw that in as a solid curve. There's my circle centered at the origin of radius 2. And now I want to figure out what side to shade. Notice that circle divides the plane up into two parts. What's inside the circle and what's outside the circle. I want x squared plus y squared to be less than or equal to 4. Let's pick a test point. I'm going to pick the origin, which is clearly on the inside of the circle. 0 squared plus 0 squared, plugging into the inequality, is that less than or equal to 4? Well, that would be 0 less than or equal to 4. That is true. So we want to shade the inside of the circle since that contains the origin. Okay, our next inequality is the linear one, y less than 2x plus 1. My boundary there will be the line y equals 2x plus 1. And because that's a strict inequality, that's going to be a dotted line. So I'll come up here to 0, 1. That's my y-intercept. My slope is 2. That's 2 over 1. So I can come up 2 over 1. And I'll connect those points with a dotted line, like so. And then we wanted y to be less than the y value on that line, so we're going to shade below. Okay, so once again, because I used horizontal and vertical shading, my solution is going to be the stuff that's checkmarked. That's what's inside the circle, but below that line. To make that clearer, I'm going to draw now a final graph. So I want just this portion of the circle. Okay. So I'm going to start by drawing the circle. I'm going to have to adjust this in a moment, though. Well, first of all, I should probably make it round. Okay, I'm going to start by drawing the circle. I'm going to have to adjust it in a moment, though, because this portion of the circle is not included in my solution set. Then I've also got this line. And I can see what I wanted was this portion of the circle. So this point and this point where they intersect are not included. They're only going to be included if I have two solid lines, and so that it was shaded twice. Okay. And so this portion of the circle is not included. I'm either going to erase that entirely or turn it into a dotted curve. I think I'm just going to erase it entirely. We've basically got this is our solution set. Now, you're not being asked to solve for these points where the line and the circle intersect. You're just being asked to show them graphically. So they don't have to be in exactly the right place, but they should be in approximately the right place. I've got one point here in quadrant 1, up and to the right a little bit from the y-intercept of the line. And then the other point where the line and the circle intersect was down here in quadrant 3. Okay. So you want to show those graphically, although you're not being asked to find the coordinates for those points. That would be solving the system, which we know how to do, but you're not being asked to do that as part of the problem. You are asked, however, not to submit this as your final answer, but to just copy what was shaded twice.